Hello learners. In the last lecture, I was discussing about number system conversion. We had discussed decimal to binary and binary to decimal conversion. Now, we move ahead with decimal to octal, then decimal to hexadecimal and vice versa, octal to binary and hexadecimal to binary number conversion. So, let us check it one by one and see how it is done. We begin with decimal to octal number conversion. Take this example of 127, which is in decimal, and we want to convert it to a different base, which is octal. We have learned already that our target base is 8. So, we will divide this number 127 with 8 and we will record two things. One is quotient and another one is remainder. So, we will divide 127 with 7 with 127 with 8. We will get remainder as 7, quotient at 15. Then we will divide 15, we will get remainder as 7 and we get 1 as quotient. Since this 1 is less than 8, so we will stop here, and as we discussed, we will read from bottom to top. So, our result would be 177 octal. Similarly, for octal to decimal conversion, we discussed that whatever base we would like to change into, when we will convert it into decimal, we will start from this digit, which is the least significant digit, and this is the most significant digit, and we will start multiplying each digit from right hand side, that is least significant digit, with the base exponent. So, we will begin with 7 multiplied by 8 to the power 0 plus 5 next digit multiplied by 8 to the power 1, then 1 multiplied by 8 to the power 2. We will simplify it, right, and we will get 64, 40 and 7. After sum, we will get this. So, our required number, which is a decimal number, and our original number, which was an octal number, and this way an octal number is converted into a decimal number. So, this was for whole number. Now, let us see what if we are having a decimal fraction which is to be converted to octal. So, we discussed that in that case we will treat integral part and decimal part separately. First, we will handle the integral part, real part, and then we will handle the decimal part. We know, just we discussed that how the integral part will be converted from decimal to octal. We will divide the decimal number 172 with octal number 8. This is our number. We have 172.41. So, we have to convert it into octal number. By simplifying this, we get 254 decimal number, which is equivalent to 172, which is the integral part of the decimal fraction. Now, in order to convert the fractional part into octal number, we will take the fractional part, which is 0.41, and will multiply it with 8, right. The result will be written in such a way that we will separate the real part and the integral part. Then we will take this integral part and we will again multiply it with 8. Again we will record this like this, real part and integral part, and we'll go on doing this till, as we discussed, we get 0. But in case if does not terminate to 0, we'll stop somewhere, or as many point as we want, we'll stop there, or as it is required. After that, in the end, we'll start reading the real part of the result from top to bottom. So we'll note down 3, 2, 1, 7, 2, and this is our octal number. Now we will combine A and B, and combining this will result into 254 and 0.32172, which is the result of the fractional part. So total the actual result of conversion of decimal fraction to octal fraction is 254.32172 octal. Now we move on to another example, how to convert octal fraction to decimal fraction. So let us again take one example. Suppose we have a number 14028 octal, and we have to convert it into equivalent decimal number. The procedure is same as we discussed for binary. We'll treat the integral part and fractional part separately. So we'll first take the integral part, that is 140 octal, right, which is left on the radix point, and then 28, which is right on the radix point, that is fractional part, which we will handle separately. So we'll start with multiplying from least significant digit, which is 0, with 8 to the power 0, plus next digit 4 into 8 to the power 1, then the most significant digit 1 into 8 to the power 2, and we'll solve this and we'll get the result 96, which is equivalent to decimal number. This is what we learned earlier. In the same way, for fractional part, we'll start right from the digit on the right hand side of the dot, which is 0.28, and we'll begin with the first digit soon after the decimal point, 2 divided by 1 upon 8 to the power 1. Then next digit divided by 1 upon 8 to the power 1. If 8 to the power 2. Next, if we have more digits, we'll keep on adding and number into 1 divided by 8 to the power 3, then 8 to the power 4, and so on. Here in this case, when we will solve it, we'll get 1 upon 4 and 1 upon 8. Solving this will result in 0.25 and 0.125, and when we add this, we get 0.375, which is equivalent decimal number for the fractional part. Now, what we learned, we'll combine the result of A and B, step A and step B. So we add A and B, and resultantly we get 96.375, which is equivalent to 14028 octal number. Next, let us see the hexadecimal number. We know that hexadecimal number has base 16 and it uses digits from 0 to 9, then 10 represented by A, next B, next C, next D, next E, and next F. F represents a number 50. Now, in order to convert a decimal number into a hexadecimal number, so what we will do, we will take the base of hexadecimal number, which is 16, and we'll divide the decimal number, given decimal number. Suppose we have a decimal number 192 base 10, which is to be converted into equivalent hexadecimal number. So we will divide this number 192 with 16, and we will record quotient as well as remainder. So on dividing 192 with 16, we get the quotient of 12 and a remainder of 0. See, this 12 is less than 16, right? So we'll stop here. Now we will see this 16 is equal to 12. So this is C, hexadecimal, and then 0, and this is equivalent hexadecimal number. So 192 decimal is equivalent to C0 hexadecimal. Next, in order to convert hexadecimal number to decimal number, let us take again an example. Suppose this is the given number 7AC hexadecimal, which is to be converted into equivalent decimal number. So the rules are same. We'll start from the rightmost digit, which is the least significant digit. Here it is C. C is equal to 12, and then A is equal to 10. Then we have 7, and we'll multiply each of these digits with 16 to the power 0, then 16 plus, then next digit A, which is equivalent to 10, into 16 to the power 1, plus next digit is 7 multiplied by 16 to the power 2. We will solve it, and ultimately we'll get the result as 1964 base 10, which is equivalent to decimal number for 7AC16, the given hexadecimal number. In the same way, we can convert octal number to binary number to octal number. The procedure would be slightly different. We will first convert the given octal number into equivalent decimal number, we have just seen. Then we will convert the decimal number to binary number. This is better method. Another way, another conversion, binary to octal. So what we will do, we will first convert the binary number to decimal number, then decimal number to octal number. So this is the natural way we will proceed. So we have discussed conversion of decimal to binary, binary to decimal, decimal to octal and vice versa, decimal to hexadecimal and vice versa, octal to binary vice versa, hexadecimal to binary and vice versa. I hope you will practice with more examples.